See this, in this today's lecture we shall discuss the useful comparison integrals. Student Yogesh Kadam, Digambar, Harish, Saili, Rutuja, Prithviraj Jadhav, Gholap, Prithviraj Shinde, Sima, Borgir, Pratiksha Shinde, Aniket Jhadke, Yogesh, Nirmohi. Okay, these are students are coming here on the online. Now see, we shall discuss the comparison, useful of the comparison integral. Now we are here in this section. Also we shall discuss the examples based on the general test of convergence. Then now up till we have studied the comparison test first, which is given by the comparing f of x and g of x. Also we have seen the comparison test second, and these theorems, by using this comparison test theorem we have to solve the problems based on this. Now see this, next we shall solve the problem next. आता या कंपॅरिझन टेस्टवर आधारित आपण प्रॉब्लेम सॉल्व करतो. ते प्रॉब्लेम्स आपण इथं आता सॉल्व करू. फर्स्ट, टेस्ट द कॉन्व्हर्जन्स convergence of the integral. First, integral from 0 to 1 dx divided by root of 1 minus x cube. Okay, actually students, we have to discuss the convergence of this integral. But before this, you tell me at which point this integral is improper integral, at which point the function is discontinuous. Now suppose tell me I is equals to integral from 0 to 1 dx divided by root of 1 minus x cube. हाँ सांगा रे students, now you tell me at which point this function is discontinuous. Can you tell me? हाँ, okay, very good. Digambar Inde, very nice. Prathamesh Salunke, Krishna Sonune, Nirmohi, Rutuja, Harshada, Yogesh Kadam, Digambar, Vaishnavi, Sima, Nikhil Gaikwad, Darshan, Rutuja, Ganesh, Omkar, Harish, Deshmukh, Golap, Aniket. Okay. Now see this, we consider the function f of x is equals to 1 upon x square, x cube. In that function, if we put x is equals to 1, then function goes to infinity. That is a discontinuity. The function is discontinuous at x is equals to 1. Let f of x is equals to 1 upon x cube, root of x cube, this function is discontinuous at x is equals to 1, x is equals to 1 in closed interval 0 to 1. Therefore, the given integral is समझो, yes, suppose this given integral is considered as a 1. Suppose this given integral 1 is improper at x is equals to 1. Now, to discuss the convergence of this improper integral, we have to use the comparison test which we have studied in the last lecture, last but one lecture. So, by the comparison test, we can check the convergence of this integral, that is, this improper integral is either convergence or divergence, we shall discuss. Now, see this here, f of x is equals to 1 upon root 1 minus x cube. Students, Aishwarya Andare, Upperward, now you tell me what is the formula for a cube minus b cube, because we can use the formula of a cube minus b cube for this function. So you tell me what is the formula for a cube minus b cube. Chalo students, likhna hai fast. 1 upon root 1 means we can write 1 cube minus x cube. So it is given by 1 divided by root of. Now use the formula a cube minus b cube here. Then we can write what is the formula a cube minus b cube in the factor form, a minus b, a square plus ab plus b square. Okay, is it correct? So we can write a minus b means 1 minus x into another bracket we can write 1 plus x square. Now we can distribute these two functions, 1 divided by root 1 minus x into root of 1 plus x square. Now clearly we know that, see this, 1 upon root 1 plus x square, this is f of x. Suppose this is equation 2. We know that the function which is that, suppose we consider this function 1 upon root 1 plus x square. Now if we put x is equals to 0 in this function, if we put x is equals to 0 in this function, suppose we consider this function as g of x, then which is a bounded, हा फंक्शन कसा असणार आहे, बाउंडेड, कारण x इज इक्वल्स टू 0 ठेवा, याची व्हॅल्यू 1 येते. फॉर x इज इक्वल्स टू 0 देन वी गेट, आता आपण याला तात्पुरतं काय करू, g ऑफ x देऊ म्हणजे तुम्हाला समजेल. कन्सिडर द फंक्शन g ऑफ x विच इज इक्वल्स टू 1 अपॉन रूट 1 प्लस x स्क्वेअर. Now see this, if we put x is equals to 0, then g of x is equals to, what is the value? When x is equals to 0, then g of x is 1. When x is equals to upper limit, what is the upper limit of this? Lower limit is 0, upper limit is 1. So if we put x is equals to 1, then 1 divided by 1 plus 1 means root 3. 1 plus 1 means suppose root 3. We take approximate value root 4. Approximate value root 4. Root 4 means square root of 4 is 1 by square root of 4 is 2. Square root of 4 is 2. So if for x is equals to 1, g of x is less than 1 by 2. Definitely we can say that g of x is less than 1 by 2. So we can say that the function here. The function for x is equals to 0, it gives a value 1. For x is equals to for x is equals to 2, the value of f of x is, suppose, greater than 1 by 2. 1 minute. Nearly approximate equals to 1 by 2. आपण समजू approximate equals to 1 by 2. म्हणजे तुम्हाला बाउंडेड आहे का सांगता येतं. 1 minute. It is approximate equals to 1 by 2. समजा equals to नाही आहे. Suppose we consider it is approximate equals to 1 by 2. Okay. Approximate equals to 1 by 2, or it is approximate equals to 1 by 1 point whatever may be. समजो 1 point, समजा 1 point root 3 चे square root किती असतं 1.2 असेल. So we can write approximate equals to 1.2, 1 by 1.2. Then for x is equals to 0, g of x is 1. For x is equals to 1, g of x is 1 upon 1.02. Means it is a bounded. G of x is in between 1 and 0 point something. So we will get the function g of x is a bounded. So we know that the function g of x is a bounded function. Now if it is a bounded function, suppose we consider its upper bound is m, let capital M be the upper bound. So we can write g of x is less than m. Therefore we can write g of x which is equals to 1 upon root 1 plus x square, which is less than or equals to m. Now put in equation 2. So from 2, suppose this is a 3, from 2 and 3, we get, how we can write f of x which is less than or equals to series f of x. Now this part is less than or equals to m. Second part, equation 2 मधला जो second part है ना, 1 upon root 1 plus x square, which is less than m. So we can write f of x is less than or equals to m divided by root of 1 minus x. Root of 1 minus x. But we have know that we know that integral from 0 to 1 dx divided by root of 1 minus x. We have already calculated this. हे आपण calculate केलेलं आहे. is convergent. तुम्ही पहा, चेक करा, हे इंटिग्रल आपण कॅल्क्युलेट केलेलं आहे. Therefore by the comparison test आदर्श जगदाळे, वेळेवर जॉईन व्हायचं रे, मध्येच कधी येऊन जॉईन व्हायचं नाही. रोहिणी का सर, तुला रोज सांगावं लागतं. अभिषेक, वेळेवर जॉईन व्हायचं, मध्येच यायचं नाही. मी अगोदर सांगायला लागलो स्ट्रिक्टली. बाय द कंपॅरिझन टेस्ट वी कॅन से दॅट इंटिग्रल फ्रॉम 0 to 1 dx divided by root of 1 minus x square is convergent. You know that suppose f of x is less than or equals to, suppose p of x, if second term is convergent, because f of x is less than this second term, and if second term is convergent, m is also real number. denominator is 1 minus x. If second term is convergent, then we can say that the given integral is also convergent by the comparison test. Okay, हे खूप theorem interesting problems आहेत, ते थोडे लक्षात ठेवा. ओके, थांबा रे, सांगा रे, इंटिग्रल कॉन्व्हर्जंट आलं का डायव्हर्जंट आलं? हे इंटिग्रलची व्हॅल्यू सांगा बरं. मी सॉल्व केलं होतं, या इंटिग्रलची व्हॅल्यू किती आली होती सांगा तुम्ही सर्वजण जे ऑनलाईन आहेत ते स्टुडंट सांगा. इंटिग्रल फ्रॉम 0 to 1 dx डिवाइड बाय रूट ऑफ 1 minus x. We have calculated this integral. What is the value of that integral? You can see and tell me. तुम्ही ते पाहून सांगा या इंटिग्रलची व्हॅल्यू किती आली होती ते. हा सांगताय का? Now you tell me the value of integral. What is the integral value? See this. So we can find the solution of this equation. अशा पद्धतीने हे सोल्युशन आपण कॅल्क्युलेट करू शकतो. ओके, हां सांगा रे, व्हॉट इज द व्हॅल्यू ऑफ कॉन्व्हर्जंट आहे पण व्हॅल्यू आली होती. नाउ यू टेल मी द व्हॅल्यू. इंटिग्रल फ्रॉम 0 to 1 1 upon root 1 minus x. 1 minus x. या 1 minus x च्या इंटिग्रलची व्हॅल्यू सांगायची हो का? या इंटिग्रलची इंटिग्रल फ्रॉम 0 to 1 dx डिवाइड बाय रूट ऑफ 1 minus x. ह्याची व्हॅल्यू सांगा मला. ह्याची सांगताय का? हा, ओके, व्हेरी गुड. 2 आली होती पहा, राईट. चलो ठीक आहे, वी शॅल मूव टुवर्ड्स द सेकंड प्रॉब्लेम. नाउ second, test the convergence of problem number 3, example number 3. Test the convergence of integral from 0 to pi by 2 sin x divided by x raised to p dx. Okay, now we have to discuss the convergence of this integral. Let students, first of all you tell me at which value of x this integral will be divergent or this integral will be improper. अशी x ची व्हॅल्यू सांगा जेणेकरून तो f of x डिस्कंटिन्युअस होईल in between 0 to pi by 2. Let I is equals to integral from 0 to pi by 2 sin x divided by x raised to p dx. Now you tell me the function, at which function this function will be discontinuous. आता तुम्हाला काय चेक करायचे पहा, at which value this function will be discontinuous. मीन्स जर तुम्ही फंक्शन मध्ये कोणती व्हॅल्यू ठेवली असता डिस्कंटिन्युअस येतो किंवा यालाच म्हणतात इट विल बी. हां, ओके, व्हेरी गुड, ठीक आहे. लेट f of x equals to, we can write sin x divided by x raised to p. This function is discontinuous at x is equals to 0 in closed interval 0 to pi by 2. Okay, बराबर है. So we can say that this integral is, therefore the given integral is improper at which value? X is equals to 0. Now we have to discuss the conditions. See this here. Here we know that इफ p इज लेस दॅन 1, p ची जर व्हॅल्यू लेस दॅन 1 असेल, लेस दॅन ऑर इक्वल्स टू 1, then this integral will be proper. If p is greater than 1, then the integral will be improper, less than or equals to 1. का आपण या पद्धतीने पाहिलेला आहे, प्रॉब्लेम पाहिलेला आहे पहा. So here for p is less than equals to 1, yesterday we have seen this, it is a proper integral. One example we have seen, for p greater than 1, the integral is improper. The integral is improper, and 0 be the point of infinite discontinuity, and 0 be the point of infinite discontinuity. Okay, you know that 0 be the point of infinite discontinuity. Now our aim is to check the given integral is proper or improper. That means we have to express in the form of separate. Now we can write this f of x is equals to sin x divided by x raised to p. We have to separate this. We can separate this. आता याला separate कसं करावं लागेल रे students? We can write this as a sin x divided by x into 1 upon x raised to p minus 1. See this. We have taken here x separate from x raised to p. स्टुडंट सांगा बरे, मी x सेपरेट का घेतलेला आहे? कॅन यू टेल मी why we can selected here x separately? Because if we take x separately, then there will be a standard form. We know that the standard form of limit x tends to 0 sin x divided by x is 1. That means we can write the value of sin x divided by x which is less than 1. So suppose this is 2. We know that comparison test वापरायच्यात लक्षात घ्या. We know that the function sin x, very good, Saili Kale, very nice, sin x divided by x is always less than or equals to 1. हा, लिमिट त्याची व्हॅल्यू 1 असते, पण लिमिट जर नसेल तर लेस दॅन ऑर इक्वल्स टू 1. So we can write, therefore put this into, by putting 2, so we can write f of x which is equals to, आता sin x by x means which is less than 1, so f of x 1, so 1 divided by x raised to p minus 1 which is less than or equals to, okay, so we can write this as f of x is, 1 minute रे students, काय झालं गेलं का ते? So we can write, आता इथं लिहितो मी, therefore we can write this as f of x equals to sin x divided by x raised to p which is less than or equals to 1 upon x raised to p minus 1, because sin x divided by x which is less than 1, so we can write this. Now we have integral from 0 to pi by 2 dx divided by x raised to p minus 1 converges if p, 1 minute, न्यूमरेटर मध्ये p minus 1. हा थेरम आपण काल घेतलेला आहे, 1 अपॉन एक ब्रॅकेट रेज टू n चा. तोच प्रोसेस आहे. कॉन्व्हर्जेस इफ p minus 1 is less than 1 or p is less than 2. या minus 1 ला या राईट साईडला घ्या म्हणजे सो वी कॅन से दॅट इंटिग्रल फ्रॉम 0 to pi by 2 dx divided by x raised to p minus 1 if converges if p minus 1 is less than 1, p is less than 2. Why we can say that convergence? If this is a less than 1, then we can write in the numerator, and if we write this denominator in the numerator, then we can put the value 0, then we can find the value of integral. Therefore we can write by the comparison test, we can write integral from 0 to pi by 2 sin x divided by x raised to p dx is convergent for p is less than 2 and divergent for p greater than or equals to 2. See this हा जो खूप महत्वाचा पॉइंट आहे. We have integral from 0 to pi by 2 dx divided by x raised to p minus 1. See this. आता x raised to p minus 1, आता पहा 1 upon x raised to p minus 1. p minus 1 जर लेस दॅन 1 असेल, यू कॅन टेक लेस दॅन 1. काल आपण प्रॉब्लेम पाहिलेला आठवत आहे का? इंटिग्रल सेम प्रोसेस, तोच इथं वापरायचा आहे. इंटिग्रल ऑफ x minus a bracket raised to n dx divided by x minus a bracket raised to n, which is convergent for n is less than 1. By using this theorem, by using that condition, we can write integral from 0 to pi by 2 dx divided by x raised to p minus 1 converges by using this. हा theorem वापरला इथं. By using this we can say that converges if p is less than 2. So by the comparison test, मग आता हा इंटिग्रल जर कॉन्व्हर्जंट होत असेल तर f of x सुद्धा कॉन्व्हर्जंट होतो, बिकॉज f of x is less than or equals to 1 upon x raised to p. So by the comparison test first, इथं comparison test first, we can say that the integral from 0 to pi by 2 sin x divided by x raised to p dx is convergent if p is less than 2. Okay. Now next we shall discuss the next problem. Write down problem number 4 or example 4. Show that integral from 0 to 1 log x divided by root x is convergent. Okay, now we have to prove this integral convergent. Let I is equals to integral from 0 to 1 log x divided by root x dx let, or here we can write here, no problem, here f of x is equals to log x divided by root x. See this, we know that the value of log x, the value of log x is negative in 0 to 1. Value of log x is negative in 0 to 1. See this, you know the graph of log x. तुम्हाला log x चा ग्राफ माहित आहे का? पहा. See, this is suppose x axis, this is a y axis, and we know that, student सांगा बरे, what is the value of log 1? log 1 ची व्हॅल्यू किती असते सांगा? Now if we want to plot the rough graph of log x, if we put x is equals to 1, then the value of log 1 is 0, means this point. See this, if x is equals to 1, then log x is equals to 0. Very good, हर्षद दलवे. If x is equals to 0, अगर आप x is equals to 0 रखते हैं तो log की वैल्यू कितनी होते हैं? Then log goes to actually minus infinity. Log x will be minus infinity, means the graph of log x is like this. Okay, so this is the log x. From this graph we can say that in between, see this, the limits of integral. Now you tell me, students, limits of integral. Log x tends to infinity. Minus infinity, you can write infinity, no problem. That is infinity. Now according to the graph, we can say that in between 0 to 1, the value of log will be negative. Do you understand this? Because we know that if x is equals to 0, then log 0 means minus infinity. That means the graph is like this. Like this. So in between 0 to 1, definitely the function will be negative. So we can write here, we have the function log x divided by root x. आता root x न multiply करा, log x is negative, negative divided by positive means it is again negative, is negative in closed interval 0 to 1. So we can take, therefore we can take f of x is equals to minus log x divided by root x, minus log x divided by root x. So that can be written as f of x is equals to minus log x है ना, ह्याला कसं लिहिता येईल पहा, minus log x divided by root x, that is a minus log x, means that is equals to log of 1 by x divided by root x. You can write the since, because the value of log 1 by x which is equals to minus log x. तुम्हाला माहित राहावा हा फॉर्म्युला. Log 1 by x means minus log x. How to write this? Log of 1 by x. That can be written as a log 1 minus log x. Log 1 ची value 0 minus log x, that is equals to minus log x. See this, students. So log of 1 by x means minus log x. So we can write minus log x as a log of 1 by x. So now you know that this function, आता इंटिग्रल मला सांगा बरे, हे फंक्शन x च्या कुठल्या व्हॅल्यूला डिसकंटिन्युअस आहे? You tell me, because integral is from 0 to 1, at which value of x the given function is discontinuous? Okay, here the function f of x is discontinuous at x is equals to 0 in closed interval 0, at x is equals to 0 in closed interval, इथं लिमिट किती आहे? 0 to 1. व्हेरी गुड. प्रीती खराडे, निर्मोही, सायली, ऋतुजा, निखिल गायकवाड, व्हेरी नाइस. Now, so 0 is, therefore 0 is the only point of discontinuity. Only the point of discontinuity. See this, are you understand this? 0 is the only point of discontinuity. इन दिस वे आपल्याला चेक करत जायचे, कंपॅरिझन टेस्ट वापरायचे. आपण एक फंक्शन कन्सिडर करू, सिंपल फंक्शन विच इज अ कॉन्व्हर्जंट. सो लेट g of x is equals to 1 upon x raised to 3/4. See this. This function is g of x. This function is discontinuous at x is equals to 0. Means we have considered another function g of x which satisfies the same condition with f of x. कारण आपण एक theorem पाहिलेला आहे पहा. Comparison test second we have seen in the limit form. If limit, what is that statement of the theorem तुम्ही आठवा, limit x tends to a positive f of x divided by g of x which is equals to L. L is the real number. L is the real number. If this limit exists, then we can say that f and g are converges or diverges together. This is the concept which we have seen. So if we consider this f of x is equal, we consider another function g of x which is as like f of x, because f of x is discontinuous at x is equals to 0. So g of x is our considered function which is also discontinuous at x is equals to 0, because we have to use the comparison test second which is in the limit form. So now you can calculate the value of now f of x divided by g of x which is equals to, put the value of f of x. What is the value of g of f of x? That is log x, log of 1 by x divided by root x, log of 1 by x divided by root x. This is the value of which term? This is the value of f of x upon g of x. Upon g of x means we can take the reciprocal of g of x. So we can write x raised to 3/4 divided by 1. Means we get the value of f of x divided by g of x. तुम्ही समजता का? पहा, व्यवस्थित समजून घ्या. That can be written as, अभी देखो यहाँ पे x raised to 3/4 divided by root x म्हणजे x चा पावर किती असतो रे? x raised to 1/2. So we can write this as x raised to 3/4 minus 1/2. After the division, we get x raised to 6 minus, बरोबर आहे का पहा, 6 minus 4 divided by 8 means it is 2/8 means 1/4. x raised to 1/4. बरोबर आहे का students? So we get the value x raised to 1/4 into log of 1 by x, log of 1 by x. Now this limit of this function goes to, limit of this function goes to, see this, which is equals to 0, approximate equals to 0, as so we can take, or we can write this as also, यालाच असं लिहिता येतं. वाटलं तर आपण सॉल्व करू, तुम्हाला डायरेक्ट नाही समजणार. So we can take this log of x. So I shall take the limit x tends to 0 positive f of x divided by g of x which is equals to limit x tends to 0 positive log of 1 by x divided by x raised to minus 1 by 4. आता आपल्याला इथे एल हॉस्पिटल रूल वापरायचे रे. एल हॉस्पिटल रूल वापरत असताना याचा डेरिव्हेटिव्ह कॅल्क्युलेट करत असताना मी बाजूला करून दाखवतो. लॉग एक्सचा डेरिव्हेटिव्ह काय असतो रे? लॉग ऑफ एक्सचा डेरिव्हेटिव्ह 1 अपॉन एक्स मीन्स 1 अपॉन एक्स इंटू पुन्हा 1 अपॉन एक्सचा डेरिव्हेटिव्ह मायनस 1 अपॉन एक्स स्क्वेअर. एल हॉस्पिटल रूल तुम्हाला आठवतं का? न्यूमरेटरचा डिनॉमिनेटरचा डेरिव्हेटिव्ह घ्या. पुन्हा डिनॉमिनेटरमध्ये एक्स रेज टू मायनस 4चा डेरिव्हेटिव्ह मायनस 1 बाय 4 एक्स रेज टू 1 बाय 4 मायनस 1 means minus 3 by 4. So we get the answer minus minus plus. That is, we can write this 1 by x 1 by x square. So minus 1 by x divided by x raised to minus 3 by 4. So we can write minus 1 by x into x raised to 3 by 4. आठवतंय का पहा? log x चा डेरिव्हेटिव्ह 1 by x असतो. Now we can write minus 1 upon x into x raised to काय येतं पाहता? हे बरोबर आहे का? पहा, चेक करा. log x चा डेरिव्हेटिव्ह log x म्हणजे 1 by x इंटू 1 by x चा डेरिव्हेटिव्ह मायनस 1 अपॉन एक्स स्क्वेअर. 1 by x कॅन्सल. ठीक आहे. आणि इथं काय तो मायनस 3 by 4चा डेरिव्हेटिव्ह. सो वी विल गेट दिस द व्हॅल्यू बाय द एल हॉस्पिटल रूल विच इज नियरली अबाउट 0 बाय द एल हॉस्पिटल रूल. एल हॉस्पिटल रूल. So we get the value, therefore limit x tends to 0 positive f of x divided by g of x is equals to 0. Then by the comparison test, हे पहा, हे कॅल्क्युलेट करा तुम्ही, येतं एल हॉस्पिटल रूल ना. Then by the comparison test, second, that is limit form. लिमिट जर एक्झिस्ट होत असेल, सेकंड, the function f and g are converges together. हाँ, ठीक है. Now see this comparison test. The integral from 0 to 1 g dx, which is equals to integral from 0 to 1 dx divided by x raised to 3 by 4 is convergent at 0. Therefore we can say that by comparison test, integral from 0 to 1 log of 1 divided by x upon root of log x is convergent. This implies that the integral from 0 to 1 log x divided by root x is convergent. And hence proved. अँड हेन्स प्रूव्ड. हे लक्षात ठेवा, एल हॉस्पिटल रूलनुसार हे लिमिट कॅल्क्युलेट करा. तुम्ही घरी करू शकतात, सॉल्व करू शकतात, काही अडचण नाही आहे. याला सॉल्व करता येतं तुम्हाला. यू कॅन सॉल्व दिस. ओके. किंवा याला खाली लिहा, लॉग एक्स लिहा, म्हणजे इथं वाटलं तर सॉल्व करून दाखवतो तुम्हाला. यू कॅन राईट, यू कॅन सॉल्व दिस लॉग ऑफ, याला सॉल्व करू शकता. ठीक आहे, सॉल्व करा. एल हॉस्पिटल रूल तुम्हाला येतो, त्याच्यामुळे हे इंटिग्रल सॉल्व येतं. लिमिट एक्झिस्ट होतं आणि बाय कंपॅरिझन टेस्ट हे वापरू शकता. ओके. हेन्स प्रूव्ड. नेक्स्ट वी शॅल डिस्कस द अनदर एक्झाम्पल. एक्झाम्पल नंबर 5. show that the integral show that integral 1 to 2 root x divided by log x is divergent. Let I is equals to integral from, मला सांगा बरं इन्फिनिटी कुठे येतं स्टुडंट्स, हे इंटिग्रल इम्प्रॉपर कुठं आहे, 1 to 2 root x divided by log x dx. Now see here, this let f of x, आता हे जे f of x आहे कुठल्या पॉइंटला डिस्कंटिन्युअस आहे, here f of x is equals to root x divided by log x. If we put x is equals to 1, then value of log 1 is 0. Very good, Harshad, very good, Rutuja Deshmukh, Aishwarya Andare. If we put x is equals to 1, then value of log 1 is 0. And root x divided by 0, that means infinity. So the given function is discontinuous at x is equals to 1. Here the function is discontinuous at x is equals to 1 in closed interval 1 comma 2. Therefore the point 1 is the only point of infinite discontinuity. Infinite discontinuity. So consider the another function g of x. Let g of x is equals to 1 upon x minus 1. See this, we have considered another function g of x such that which is also discontinuous at, सांगा रे स्टुडंट्स, हा g of x कुठं discontinuous येतो, which is at discontinuous at x is equals to 1. That means we have to consider two functions f and g such that both are convergence and diverges together at particular point, because we have to use theorem number second, comparison test second in the limit form. So we can write now limit x tends to 1 f of x divided by g of x, which is equals to limit x tends to 1. Put the value of f of x. F of x means root x divided by log x into g of x means upon g of x आहे त्याला रेसिप्रोकल घेऊन लिहा x minus 1 divided by 1. So we can write limit x tends to 1 root x means x raised to 1 by 2 into x minus 1 divided by log x, that is equals to limit x tends to 1. Generally positive घ्या लिमिट, पॉझिटिव्ह, कारण जर लोअर इंटिग्रल लोअर लिमिट असेल, लिमिट एक्स टेन्स टू 1 म्हणजे लोअर लिमिट आहे इंटिग्रलचं, वी हॅव टू टेक इट इज अ पॉझिटिव्ह इन द फॉर्म लॅम्बडा टेन्स टू पॉझिटिव्ह इन दिस वे. वी कॅन मल्टिप्लाय दिस x raised to 1 by 2 into x means x raised to 3 by 2 minus x raised to 1 by 2 divided by log x. Now use the L'Hospital rule. Limit x tends to 1 positive. L'Hospital rule म्हणजे डेरिव्हेटिव्ह घ्यायचा, न्यूमरेटरचा डेरिव्हेटिव्ह, डिनॉमिनेटरचा डेरिव्हेटिव्ह, 3 by 2 x raised to 1 by 2 minus 1 by 2 x raised to minus 1 by 2 आणि log x चा डेरिव्हेटिव्ह काय असतो रे, 1 by x. इथं सिन्स म्हणून लिहा L Hospital rule. So we can write this as, therefore limit x tends to 1 positive f of x divided by g of x, which is equals to limit x tends to 1 positive, what is that value series? X 3 by 2 into x raised to 1 by 2 minus 1 by 2 x raised to minus 1 by 2 divided by 1 by x. आता लिमिट ठेवा, x ची व्हॅल्यू ठेवून टाका 1 means 3 by 2 minus 1 by 2 divided by 1. So 2 by 2 means 1. That means limit x tends to 1 positive f of x divided by g of x, which is equals to 1. That means limit exists and which is a real number. आता आपण theorem पाहिला, comparison test second पाहिलेले आहे. If limit x tends to a positive f of x divided by g of x, which is equals to L, then we can say that f and g are, converges or diverges together. F and g are converges and diverges together. So here integral from, now see this, so we can write this g of x. So integral from, here the integral from 1 to 2 dx divided by x minus 1 means g of x. I shall write here g of x, which is equals to integral from 1 to 2 dx divided by x minus 1. Diverges, हा डायव्हर्जंट होतो, तुम्ही काढून पहा, लिमिट काढा, डायव्हर्जंट येतं, डायव्हर्जेस. सॉल्व करायला तुम्ही हे लिमिट आपण जसं अगोदर इंटिग्रल सॉल्व केलेत ना, लॅम्बडा टेन्स टू 0 पॉझिटिव्ह घेऊन सॉल्व करा, हा डायव्हर्जेस येतो, diverges. Therefore by the comparison test, second, the integral from 1 to 2 root x divided by log x dx is also divergent and hence proved. अशा पद्धतीनं हा प्रॉब्लेमचा पार्ट संपलेला आहे. अशा पद्धतीनं हा जो प्रॉब्लेमचा पार्ट संपलाय, जसं इथं एल हॉस्पिटल रूल वापरलं ना, सेम तिथं सुद्धा एल हॉस्पिटल रूल वापरा तुम्ही आणि सोल्युशन काढा, येऊन जातं आन्सर. ओके, सो वी विल गेट द रिझल्ट. अशा पद्धतीनं हा आपला रिझल्ट येतो. ठीक आहे. ओके, नाउ वी शॅल स्टॉप हेअर. अशा पद्धतीने इथं आपण थांबू. नमस्कार, गुड बाय. हे इथं लक्षात ठेवा रे, लिमिट काय घेतलं होतं, हे 0 पॉझिटिव्ह घेतल्यामुळे ह्याचा रिझल्ट 0 आला होता. पहा, काय अडचण आली तर विचारा, काही प्रॉब्लेम कुठला पार्ट नाही समजला असेल तर विचारा, मी तुम्हाला सोल्युशन परत एकदा सांगतो. ठीक आहे. तर हे प्रॉब्लेम नीट करा. हा प्रॉब्लेम खूप महत्त्वाचा आहे. दोन्ही प्रॉब्लेम खूप इम्पॉर्टंट आहेत सिरीज.